Welcome to Power Snack, a short-form segment of the Power Edge by BSD Business Consulting. I'm Katie Davey, and today's quick point is this.
AI's first real bottleneck may not be chips. It may be power. For the last few years, the AI conversation has been dominated by GPUs. Everyone talks about who has the most advanced chips, who can train the biggest models, and who can build the fastest systems. And yes, chips matter, but a chip without power is just an expensive piece of silicon sitting in a rack. That is the part most people miss. Artificial intelligence is not only a software race, it is becoming an infrastructure race. AI workloads need dense computing environments. Dense computing environments need more electricity. More electricity creates more heat. More heat requires more cooling. More cooling requires more power. And all of that depends on whether the facility, the utility, and the grid can support the load. That is where the real constraint starts to show up. A company can buy servers. It can raise capital. It can lease space. It can announce an AI strategy. But if the site cannot get enough power, the strategy slows down. If the electrical infrastructure is outdated, the strategy slows down. If the cooling system cannot handle higher density workloads, the strategy slows down. If utility interconnection takes years, the strategy slows down. This is why power availability is becoming one of the most important questions in AI deployment. Not just, do we have the model? Not just, do we have the data? Not just, do we have the GPUs? But, can the building actually support what we are asking it to do? That question matters for data centers, but it also matters for hospitals, universities, manufacturers, financial institutions, and large commercial facilities. Because AI is not staying inside Silicon Valley. It is moving into healthcare. It is moving into logistics. It is moving into public services. It is moving into operations. It is moving into buildings that were never designed around AI-level power density. That creates risk. A facility may have enough power for today's IT environment, but not enough for tomorrow's AI roadmap. A backup power system may protect current operations, but not future compute demand. A cooling system may be adequate for standard server loads, but not for high-density AI equipment. And a utility connection may be fine for normal growth, but not for a sudden jump in electrical demand. That is why infrastructure planning has to move upstream. Power cannot be treated as an afterthought. Cooling cannot be treated as a facility's detail. Backup systems cannot be treated like insurance nobody thinks about until something fails. These systems are becoming part of the AI strategy itself. The organizations that understand this early will ask better questions before they invest. How much power will this AI workload require? Can our current infrastructure support that demand? What happens if we scale? Where are the cooling limits? Where are the uptime risks? What upgrades are needed before the technology becomes mission critical? Those questions are not glamorous, but they are the questions that decide whether AI works in the real world. Because the future of AI will not only be shaped by who has the best algorithms, it will be shaped by who has the power to run.
This has been Power Snack, a short-form segment of the Power Edge by BSD Business Consulting. If your organization is planning around AI, start with the question most people skip. Is the infrastructure ready?